Good morning. My name is Daphne Cabral, and this is the required sheet for this presentation. Okay, so today we will be discussing the female reproductive system as well as the feedback loops that control or regulate the reproductive system. And we will also be talking about it in a non-gravid sense, which basically means not pregnant. Okay, so on the slide we'll be talking about female reproduction, and female reproduction is a very cyclic physiological process, and the interaction of various feedback systems and reproductive hormones is one of the most complex control systems in the body. There are two cycles, being the ovarian cycle and the uterine cycle, that make up the female reproductive system. And the ovarian cycle consists of the follicular phase, ovulation, and the luteal phase. While the uterine cycle, it's composed of three phases as well: the menses phase, proliferative phase, and the secretory phase. And for the purposes of this presentation, we will be mainly focusing on the ovarian cycle, and we will be touching on menstruation as well. Some of the hormones involved in the regulation of these processes are gonadotropin releasing hormone, which comes from the hypothalamus, as well as follicle stimulating hormone and luteinizing hormone, which come from the anterior pituitary. And we will also be talking about estrogen, progesterone, inhibin, and anti-Mullerian hormone, which all come from the ovary. On these next few slides, we will be discussing the hormones and their effects on these cycles. Oh, and on this diagram, you can see estrogen on the bottom here and inhibin, as well as progesterone. Also up here, you can see follicle stimulating hormone and luteinizing hormone. And you can see that there's a large, surge with luteinizing hormone versus follicle stimulating hormone, which is a little bit of a shorter surge. Okay, so on the slide, I will be talking about the early part of the follicular phase. And day one of a cycle begins with menstruation because it is very easily observed. Even before a cycle begins, gonadotropin is secreted, and then afterwards, follicle stimulating hormone allows for follicles in the ovaries to mature. Then granulosa cells, which are controlled by follicle stimulating hormone, and thecal cells, which are influenced or regulated by luteinizing hormone, start to produce steroid hormones as these follicles begin to grow. Anti-Mullerian hormone is produced by the granulosa cells, and the purpose of it is to decrease follicle sensitivity to follicle stimulating hormone, or basically to prevent the too many follicles from developing at one time. Thecal cells make androgens and enter the granulosa cells. Their aromatase converts the androgens into estrogens, and as a result, estrogen levels will increase. And the increasing of estrogen levels has a few different effects. One of them is a negative feedback response on follicle stimulating hormone and luteinizing hormone secretion. As a result, the development of follicles begins to stop, or the additional development of follicles stops. Estrogen also causes a positive feedback response because it acts on the granulosa cells and promotes additional estrogen production by the follicles. This occurs even though follicle stimulating hormone and luteinizing hormone levels begin to decrease. So estrogen basically has two purposes. It works as a negative feedback system on the pituitary and follicle stimulating hormone and luteinizing hormone, and it also works as a positive feedback system on and has its effect on granulosa cells to produce more estrogen, although the follicle stimulating hormone and luteinizing hormone levels tend to decrease. So as estrogen from the follicles estrogen will allow for the follicles on the endometrium to grow, and as a result, the efficiency of blood supply increases to transport oxygen and nutrients to the growing endometrium. So basically, estrogen provides a little bit of nutrients, it allows for the efficiency of nutrients and oxygen to to reach the endometrium and allow it to continue to grow. In this diagram, we see the feedback loops we have just discussed and the negative feedback on gonadotropin releasing hormone, which is right here, as well as follicle stimulating hormone. And then we have luteinizing hormone. We have luteinizing hormone right here. And all these have a negative feedback, which is caused by estrogen. And there's also, we also see the positive feedback of estrogen on the granulosa cells that we just discussed. And anti-mullerian hormone right here, which prevents the follicles from developing. Okay, so on this slide, we will be discussing the mid to late follicular phase, and during this period, ovarian estrogen reaches its peak. The granulosa cells start to secrete inhibin and progesterone along with estrogen. Now, estrogen exerts a positive feedback effect on the gonadotropin releasing hormone, which causes a surge before ovulation. As a result, luteinizing hormone has a major increase. And I believe that's what we saw in the first slide. So right here, we can see the major increase. Okay, so follicle stimulating hormone also increases, but like what we saw before, not as much because of inhibin and estrogen suppressing its secretion. So therefore, now we know that this peak is a lot shorter because inhibin and I believe it's inhibin and estrogen which cause the peak and the surge to be suppressed, whereas luteinizing hormone does not have that suppression, so it's able to have a higher surge. Okay, so the surge of luteinizing hormone is very important because it releases chemical signals, and those are necessary for oocyte maturation. Also, high levels of estrogen at this phase cause the endometrium to continue to grow, and it prepares the uterus for a potential pregnancy or ovulation. Looking at this diagram, we can see the effect of the hormones at this stage. If we compare it to the diagram on the last page, we can see that there are more positive feedback systems in this stage of in this phase. And we see a lot more negative feedback systems over here. So essentially, there's like somewhat of a swap in a way. I mean, there's still a negative feedback system on follicle stimulating hormone because of inhibin and estrogen, but there's also positive feedback with a lot more positive feedback systems which occur because of a high estrogen output, and that has a positive impact on gonadotropin releasing hormone, luteinizing hormone, and luteinizing hormone. We can also see here that progesterone also contributes to the positive feedback on gonadotropin releasing hormone. So next we will be discussing the feedback mechanisms that occur during the early to mid-luteal phase. During this phase, progesterone is the dominant hormone, and progesterone and estrogen are responsible for the negative feedback responses on the hypothalamus and the anterior pituitary. And this also shuts off the follicle stimulating hormone and luteinizing hormone. Also, inhibin suppresses the gonadotropic secretion and remains so throughout most of this phase. In this diagram, we can see there are no positive feedback mechanisms compared to the last diagrams we looked at. However, the body is still able to prepare for pregnancy. Blood vessels continue to grow in the connective tissue, and endometrial cells deposit lipids for embryos to receive nutrients. Also, the cervical mucosa thickens. And these effects are mainly due to progesterone, the dominant hormone of this phase. So you can see a lot of negative feedback systems over here, and we can see that there's a negative feedback on gonadotropin releasing hormone and somewhat of one on the anterior pituitary right here. And that basically has an effect on follicle stimulating hormone and luteinizing hormone. how and all of this negative feedback stems from the increase in estrogen, increase in progesterone, and an increase in inhibin. But mainly, the most effective hormone in this process during the early to mid luteal phase will be progesterone. Lastly, we will be discussing the late luteal phase and menstruation. During the stage, if pregnancy does not occur within 12 days, the corpus luteum will undergo apoptosis. While this occurs, progesterone and estrogen secretion decreases. It also stops the negative feedback signal on the anterior pituitary and the hypothalamus. As a result, follicle stimulating hormone and luteinizing hormone increases. The remainder of the corpus luteum becomes inactive. Without progesterone, the endometrium cannot survive because it lacks nutrients and oxygen. As a result, the endometrium loses its surface layer, and 14 days after ovulation, menstruation commences. Menstruation usually lasts about 3 to 7 days into the follicular phase of the next ovulatory cycle. In this diagram, you can see follicle stimulating hormone and luteinizing hormone production increasing and developing new follicles, which brings us back to the beginning of the cycle. And also, I forgot to mention that menstruation is basically shedding of the endometrial surface layer. And then back to this diagram. You can see that the increase in follicle stimulating hormone and luteinizing hormone is what causes new follicles to begin to develop. And right here you can see that the corpus luteum dies and the estrogen and progesterone levels will decrease. And that brings us to the end of the presentation, discussing the feedback mechanisms of the female reproductive system.